Hello, and thanks for being here for my talk, 10 Common Mistake with Kubernetes and Containers. Uh, Before starting, I just want to share a little bit more about myself. I'm currently based in Berlin. I'm a tech lead at Infarm. It's a vertical farming company. We grow plants using software. I'm a Python Software Foundation Fellow, and I run pybootcamp.com, which is a training and consulting company focused on Python and DevOps. So I want to talk about 10 mistakes that you can make with containers and with Kubernetes in general. And the first one that you can do is to use containers wrong. The truth is that you don't always need containers. There are some use cases that perfectly fits using containers, but there are others in which containers are just creating overhead. A good example is probably when you're using Lambda functions or cloud functions. In that case, like if you have like a complex system of services, like if it doesn't make a lot of sense using Docker Compose, or you don't have like external dependencies, like building containers and maintaining Docker files takes time. So if you don't need them, it's totally fine. So feel free to just build dependencies with pip or with Poetry or with any other system, and you can just keep having Docker files and containers. So the second mistake that you can make is to forget about zombie processes and forget about how to handle signals properly. And I have a snippet for this. So, I mean, this is a super simple Python application. Like we are just calling the main function, and the main function is looping over a range. We're printing a variable, and we are sleeping. And if you press like Control C, you're going to send a signal to your application. But when you run your application inside a container, you need to be careful because you need, like, the Docker container needs to communicate the signal properly to your application. And if you don't do that, like the container runtime is going to kill your application. And if you don't manage this properly, it's going to be pretty hard to do any kind of complex, I don't know, rollout or rollback in your Kubernetes cluster or in any sort of orchestrating system. Because by default, the Docker runtime doesn't pass the signals. So if you don't specify something, the runner for your application is going to be a shell. And by default, the shell doesn't pass the signals. So there are different ways that you can improve this. There is, I like to use Tiny, which is it's a process manager basically. And apart from taking care of the zombie processes, so it takes care of killing processes which doesn't have like a parent anymore. They also pass signals correctly. And once again, like signals are fundamental because all the, like, especially for Kubernetes, all the life cycles of your application are managed through signals. Like Kubernetes, the Kubernetes scheduler communicates with your application by using signals. So if your application is not able to read and to use the signals properly, like you can forget like doing zero downtime deployment. Another mistake is invalidating Docker build cache. So every time that you build a Docker image, you use a Docker file. But that Docker file is a collection of instructions. And every time that you change something there, the Docker container is going to invalidate the cache and it's going to start from there. I think this example is directly from the Docker website. And this is a good starting point because we copy the requirements inside the container before copying the source code. And this is important because your source code is probably going to change often. But it's not the same case for the requirements. And like if every time that you change your source code, but your dependency are not changing and you copy your dependencies before, then you're going to pip install everything every time. That's probably something that you want to avoid. So this is a good example how you can construct your Docker file, like copy the requirements first and run your pip requirements. and then you copy the rest of your source code. So in this case, if you change your requirements and you run Docker build again, you're gonna start from line number 5. But if you don't change your requirements and you only change your source code, then the only structure that you're gonna execute is from line 9. So you're gonna save a lot of time because basically you're just copying files without running pip install. So try to be smart about the way in which you create your Docker files. Like every time that there is a change and you're starting from the top, you're invalidating all the layers below. So if you have any, I don't know, m variables or anything that can change like this, like the source code in this example, try to put at the end of your Docker file. Latest. So every time that, like, if you build a Docker image and you don't specify a tag, the tag is latest. And latest is not latest. Latest is just a default tag. And that means that if you pull an image without specifying the tag, you get the default image, which I don't know why they decided to call it latest. But latest is not equal to the last image that you put to Docker registry. So if you do a deployment and you say to your Kubernetes cluster or whatever system you're using to deploy latest is not really the latest. So I will gently recommend you to stop using latest. There are better approaches. One approach that I suggest is, depending on your release process, either to tag your image with the release number or with the Git hash. I prefer the Git hash. You have much more granularity. And then you just deploy the image with that tag or with the release number. Big images. This is another mistake, and is especially true if you're working with Python, because the runtime is pretty big and the dependency also pretty big. So it's easy to get, like, to end with images which are, I don't know, 500 mega, 1 giga. And there is no like an easy solution for this. There are languages that, for different reasons, are doing much better. Go is a good example. Like a Go image for an application is, I don't know, 10 mega, 20 mega. But with Python, it's different. So what I would suggest is to use Ubuntu or Debian Slim. They're pretty much comparable with Alpine right now. And try to use multi-stage builds, which is a way to just take the layers that you need from Docker image. So when you build an image, there are like you're building your image, and probably you need dependencies, and your dependencies need other dependencies. I don't know, compilers or libraries that you need to pull in. These are things that probably you need when you build a Docker image, but you don't need at runtime. You don't need for your production image. So something that you can do is, I'm going to create a Docker image to build the dependency, to create my Python packages, and then my production image, it's just going to take the layers that it needs. And in this way, like, you can really lower the size of your Docker image. Like it's not going to change. It's not going to be like 50% smaller, but you can save a couple of hundreds of megabytes. Mistake number 6: Kubernetes is not a strategy. Like if your company has a strategy and the strategy is around Kubernetes, that's probably not a good sign. I really like this one. Like, I need to know why moving our app to cloud didn't automatically solve all our problems. You wouldn't let me re-architect to be cloud native. Just put in containers. You can't solve a problem by just saying techie things. Kubernetes, and this is a classical, like this is like a classical example that I see quite often. Like moving to Kubernetes is not going to give you, I don't know, a DevOps culture the day after. It's not gonna streamline your deployment. Like it's a tool, it's a complex tool, and to be honest, I wouldn't like to use it, but it's the best one that you can have right now. But like if you have a strategy, like if you want to improve your deployment process, like your strategy should be around something else. Like Kubernetes is just a tool, and if after you evaluate Kubernetes, you find that it's just too complex, like there are many other solutions that you can consider. You can consider to run Kubernetes as a managed solution. Yeah, you can think about GKE by Google, AKS by Azure, EKS by all this strange name by AWS. There are thousands of like providers. DigitalOcean has a Kubernetes offer. So like, don't think about Kubernetes as a strategy. Think about Kubernetes like a tool. And another thing is Kubernetes is really complex. Like, you can use Kubernetes to run your application, but there are companies that are using Kubernetes to run, like, I don't know, to multi-tenants, like cloud system. So it's a big system, and as such, it really caters for multitude of needs. And for many companies, that's just too much, and there's a lot of complexity that you need to manage. So again, think about Kubernetes like a tool. Another thing that I would suggest is to consider other things. I think Nomad by HashiCorp is a really good orchestrating system. It's simpler, and not just to understand, but also to manage. So try to focus on another thing. Like, if you need to improve your deployment process, Kubernetes is one of the things that you can consider, but it shouldn't be a strategy. Point number 7 is about not using probes properly. And getting back to the complexity of Kubernetes, when you define a deployment, when you define a pod, you can define different probes, which are basically health checks. So this is a definition of a pod, and if you see on line between line 13 and line 17, we have a liveness probe. Like, Kubernetes has 3 different probes: liveness, readiness, and startup probes, and they all mean different things. And because they are there, they are helpful in different ways. So liveness is to check whether the liveness of your probe, whether your container is ready to is able to receive requests. And Kubernetes, when your application is failing, one of this probe has a different behavior. Like, if your liveness probe is going to fail, it's going to kill your container. It's going to start a new one because it thinks that, okay, the application is stuck. With the readiness is something different. Like, readiness is something that you should use to communicate with Kubernetes that your application is ready to receive requests. So, for example, they can add your container to a load balancer. Startup, for example, is something different. But you really need to be careful and to think about this. Think about the usage of the probes in sort of holistic way, because, like, you can think, okay, my application is stuck. It's killing the application is probably the right way, but maybe you're receiving a lot of requests, and your application starts to answer to the liveness probe with a 400. So the application starts failing the liveness probe, but it's because it's receiving a lot of requests, not because it is stuck. So if the liveness probe fails, then Kubernetes is going to kill the container. So, like, the problem are going to escalate in the sense. So try to be mindful with the probes. They are really useful, but it's really easy to hurt yourself if you use them in the wrong way. I think the documentation on the Kubernetes side is really good. I would suggest you to check them. If you're starting with something and you need to put, you need to put something there, I would suggest to start with the liveness probe. It's probably the simplest one to implement, and usually what I do is implement a health Z or a health check endpoint if it's a web application, and then the Kubernetes system will ping this endpoint to check the response. You can put the period, you can put the initial delay after you set containers. It's really programmable in that sense, and again, it's really useful. And it's really important to set the probes correctly, because you're going to manage the deployments in this way. So when you do a rollout, when you do a new deployment in Kubernetes, the probes are used to decide whether the deployment was successful or not. Like, so if you have 3 containers and you do a deployment, Kubernetes will try by default to create a new one, check that the liveness probe is okay, and then it will turn one off, and then it will continue the process until the rollout is complete. So it's really important to get the probes right. Otherwise, like you're going to have a lot of problems when you're doing like deployments and all these sort of things. Mistake number 8, CI/CD is not fully automated. So I know people that are using Kubernetes and they do migrations from their computers. That's not ideal. Like, because of the complexity of the system, like every time that you need to interact with the system manually, that's a source of problems or downtime. YAML files are long, sure, are readable, but there are like so many things there that you don't want to check them manually. Like you don't want to deploy things from your computer. So ideally, your like continuous integration, continuous deployment should be fully automated. A good example, it's, I don't know, on the testing environment, you can deploy automatically, and if you need to release something to to staging, UAT, or production, it's just one click. But if you need to manage, I don't know, change something manually inside the manifest, or run something from your computer, that's a big red flag. So try to improve that process, and you can also integrate the migrations and on like a lot of other things and checks inside your manifest, inside your Kubernetes manifest. Okay, point number 9, limits and requirements. So there are two different things in which you can use to define pretty much the resources of your application. You can think about CPUs and memories that you want to dedicate to your containers. And one of these is requirements, which helps the Kubernetes cluster to manage the resources. Like I need 2 CPUs and 1 gig of RAM. And then Kubernetes will use this information to schedule the application or to increase the cluster size. Limits are limits in the sense that if your application is going to go beyond these limits, then Kubernetes is going to do a different thing. In case it's going to be above the memory limits, it's going to kill your application. So you're going to get out of memory error. But if the CPU is going to be above the limits, then you're going to get throttling. But all these things, especially the limits, they need to be managed and they consume a lot of resources. So a better approach from my perspective is to drop the limits, just remove them, don't use them. If you're running a Kubernetes for your company, trust your user, trust your developers, and work together with them. Drop limits are not that useful at the end. It's important to monitor like the usage, to monitor the resources, but you should use requests. Like if you monitor your application, and if you see, okay, I need 2 gig of RAM for this application plus I don't know, 2 CPU or 2 virtual CPUs. That's something that you can put inside your request definition. And it's really important because if the cluster doesn't have resources for what you define inside your container, then it's not going to deploy your application. So if you define a container that needs to have 2 giga and has 2 CPUs, and the cluster doesn't have resources for that, you're going to get an error like waiting for scheduling because the resources are not there. So it's really important to, again, do these things right. Just removing these values are just increasing the issue. So it's really important. Like if you have developers that are, or you work in a company where you build it and you run it, it's really important to sit together with the developers, whether you are an SRE or you work as a DevOps engineer, and help them understanding their application and what is the workload for their application. And my last point is security comes first. There is this thing called DevOpsSec, but I think that the important thing is that you really need to consider on like security first. It's like it's not just a checklist. It's something that you continuously do. And it's not just something that you read on the newspaper. Like recently, I had the experience that working as a startup for the next round of funding, we got like a security audit because that's something that the investors were requiring. And some of the checks that they perform, they're really simple, like checking whether you're using admin and as a user and 1, 2, 3, 4, 5 as a password. But there are like others which are more in depth. A good example for like containers and Kubernetes is like by default, when you're running a container, when you're running an application inside a container, like you're using root. And a better approach is to create a user to run your application, which is not the super admin. Another thing is that Kubernetes has a really complex and granular system of permissions, like RBAC. And so like try to be mindful about the way in which you use that. Like not everyone needs to be admin. Not all the application needs to have access to all the things. And another thing that could be misleading is that secrets in Kubernetes are not secrets, are just a way to encode certain information. So by default, inside Kubernetes, you can share configuration, let's say, through config maps, which are basically a dictionary hash map that you can share, and that you can define, and then you can attach to containers, or you can define secrets, which are hashed config maps, basically. So it's really important to like having secrets is better. Like if you need to share information, it's better to use secrets than using config maps. But just remember that if you have access to a Kubernetes cluster, generally speaking, you can access the secret. So there are like different ways to handle this. For example, if you're using a solution from a cloud provider, you can integrate your secrets with their secrets management system. Usually it works really well. So by default, like if you're deploying manifests related to secrets, just be mindful about this. Don't put secrets inside your repository, and try to avoid putting not encrypted secrets inside your cluster because they are not encrypted. And a couple of takeaways. So Kubernetes is here to stay. It's probably one of the biggest open source project right now, especially from the number of contribution and contributors. It's probably one of the biggest open source project which are supported by Amazon, Google, and Microsoft. If you want to play with it, like apart from okay, I'm gonna pay for a couple of virtual machines, or I'm gonna use, I don't know, a managed solution. You can try also on your computer. There are a couple of cool projects like Kind or K3D, where basically you can run your Kubernetes cluster inside containers on your machine. And another thing is that like hands-on experience for developers is becoming a requirement. Like having experience with one of the cloud providers, but with the cloud provider in general, whether it's AWS or another one, and like hands-on experience of Kubernetes is something that I see more often. Like you should be like, we're using Kubernetes, so we expect you to know how to deploy application there and all this sort of things. So yeah, don't think that is only something related to DevOps people or ops, and they're gonna take care of your application. Like usually when I see this, it's not really, it's a really bad experience for the company and the developers. So thanks for your time. I'm happy to take questions, and I have a course for Kubernetes for developers. So it's something that I'm currently recording, and it's under pre-order. So if you're interested, just check the website. Thank you.
Thank you for your presentation. I just wanted to mention to everybody who's listening that, of course, we won't hear any actual applause, but we encourage you to leave a virtual applause by reacting to the video either on YouTube or on Facebook. And as always, feel free to ask questions. That's the best time to ask them. I can see that we have one question right now. Question from Arthur. Are there any common mistakes to keep in mind when running databases or other stateful apps on Kubernetes?
Yes, don't run them if you're not an expert. So you can run databases on Kubernetes, but again, you need to be mindful because, I mean, Kubernetes really shines for stateless application. If you have stateful application like databases, then you need to be uh, really careful about managing the storage and all this sort of resources. And there is also another problem, which is the I/O. So if you care about performance of your database, generally I suggest to run the database outside of Kubernetes. That's my suggestion. But like if you need a system where, like if you need to test things and you don't want to pay for, I don't know, like an RDS on AWS, or you don't want to create a database every time, then using, I don't know, Postgres inside um, a Kubernetes cluster is totally fine. It's just that managing like stateful application like databases inside Kubernetes is not easy.
All right, thank you. We have another question from Tomasz. Talking about resource limits and requests, did I understand correctly that it's better to only define the requests? The limits are then set the same or ignored?
So, yes. The thing is that when you use limits, you're basically telling Kubernetes to continuously check these limits. And it's not super easy to have adaptive limits. Like, let's say that you put a limit for your application and you're receiving a spike. Like, if it's like a memory limit, like your Kubernetes cluster is going to kill the application, which is probably something that you don't want. Like, so like I wouldn't suggest you have Kubernetes to have the role of controller. Like if we think about Kubernetes like a scheduler, then I would suggest to use resources. The thing is that what I suggest, the total plan, like total workflow, is to have resources, and then you have alerts or metrics on top of your resources. Like if you see that your system is using, I don't know, 30% more or 40% more of your resources, then it's something that you should check. But when you leave Kubernetes killing your container just because, I don't know, you receive a spike, that's not something ideal. And the other thing is that for CPU, like the only thing that the container runtime does is throttling. Like it's just slowing down your container. But like this has a cost on the Kubernetes scheduler and the Kubernetes system. So it's better to remove this constraint and use resources together with a monitoring place on the usage of your application.
Okay, thank you. We have one more question from Sunrise Sun. What's your favorite logs solution and why? With a little bit follow-up question to also add logging and metrics to that, so to tell about both.
Yeah. So that's a really good question. Depending on the implementation of Kubernetes that you're using, you can get so you get these things out of the box. So like Kubernetes is well integrated with Prometheus, and like by default, when you run a Kubernetes cluster, the only thing that you need to have is a log collector, and then you can centralize your logs basically. But a big part of the heavy lifting is already done by Kubernetes itself. Then you can specify a daemon, and then they collect logs for you. But if you're using a managed solution like GCP or Azure or AWS, like then you get all these things out of the box. Like I can talk about GCP because it's probably the solution that I know really well. And with GKE, you get a system which is fully integrated with their monitoring stack, which was Stackdriver, and now is GCP operation. And you get all these things for free. Like you just pay for the service, but you get centralized log, cluster based, and you also get alerts and monitoring on the Kubernetes metrics. So when you create a new cluster using Gkey, you get all these metrics and dashboard for free. So if you need to build these things from scratch, there are a lot of open source projects that I recommend. You can check Prometheus. I would recommend you to use structure log, so you can search by logs, by attributes of your logs. But yeah, generally speaking, try to prefer a managed solution. Otherwise, you for sure you can find something in the open source community, but you will have to manage a lot of other systems.
All right, thank you. I believe we have 1 more minute for questions. So last time to send if you would like to ask about anything. All right, we don't see any other questions. Sunrise Sun messaged thank you. Tomasz, from the previous question messaged thumbs up. So I guess that everything is fine. All right, so once again, thank you for your presentation. Once again, I encourage everyone to leave a virtual applause, and it was great to have you here. I just wanted to remind that in the meantime, we're having a competition. So if you would like to take part in that and win a PyCharm professional license, just make a photo of how you're watching Pykonik and send that either on Facebook with a Pykonik mention or on the Slack general channel. We will be we will get the 2 winners in 45 minutes. And in 3 minutes, we're coming back with the second presentation from Jason, the presentation about exploration of shells, environments, and packages. Once again, thank you, Christian, and we'll be back with you in 2 minutes.
Thank you for having me here.